In 5.5, the whole idea is that you'll apply this. There's really just going to be two main types of problems taught in the notes, and that's where you determine the best method. And after doing that, they tell you, you of course need to solve it. So over here off to the side, remind yourself of what you've learned so far. There's three ways. There's graphing to solve systems of equations, substitution, and lastly, elimination. I really doubt you'll ever choose graphing by choice, unless you have a software and you're just typing this into a computer. And then the second least favorite is usually substitution and then elimination. When we look at all of these, I think you'll notice that parts of them are pretty nicely stacked up. The other thing too is that if you wanted to substitute, getting y by itself usually means people have to deal with fractions, and that's a little bit undesirable. So in problem 1, as you rewrite it just like you would in your textbook, were this already solved, where it was say x is negative 2y plus 94, we'd probably take that and just plug it in. But since it's not, I think I'm going to prefer to use elimination and multiply this by a negative 4. So then when I set up and stack my first equation on top of my changed second equation, so there's negative 4x minus 8y, and then if you ever needed to do something off to the side because you didn't have a calculator, it's best to write it here. That way it doesn't really get in the wrong spots within your problem. And after putting these two together, these of course go away. So I have negative 5y equals, so there's negative 195, which will now divide by a negative 5, leaving us with y equals positive 39. Given the choice of which of these two to plug into, I'll go with the original on the second one, and I'll write x plus 2 times 39 equals 94. So that becomes x plus 78 equals 94, and then once we subtract, we'll say that x is 16. I'm checking my math to make sure I'm not messing up. There I am summarizing my answer, and I just plugged both of them into the calculator and we're good to go, because it checked out in my original two equations. Alright, so again, we have to choose the best method. Last time we chose elimination, and these are almost stacked. Now instead of showing times a negative, I don't think that we're risking making a mistake if we flip the signs. I don't think that'll make any problem. So here's 7x equals negative 7. Now from here on out it's just repetition, so finish this on your own. I'm going to put the results up in a few seconds. Pause this. I'll leave the results up here just for a couple seconds for you to check your work. So on this third one, go ahead and take a moment to decide what you would do. Pause the video if you need it. I'll start explaining now. As with all of these, graphing, as well as, just getting one variable by itself, which would really set you up nicely for substitution, is a little bit tedious. So I'm going to go with elimination on this one. And if I look at it, that's going to be the most simple way to set it up. So here I am doubling the first equation, lining it up with the second, scanning through to make sure that you doubled everything in the first and rewrote everything in the second correctly, to where you'll have 11x is negative 22, and x is going to be negative 2. Plug it into the first one, may as well. You get negative 6 minus 4y is negative 10, negative 4y is negative 4, and y is 1. Summarizing, negative 2, comma 1. And then when you check it in the original, you get negative 6 minus 4 is negative 10. When you check it in the first one, you get negative 10 plus 8 is negative 2. So like I said, most of these, usually we're going to prefer elimination. But you're determining the best method that you see fit.